Hello, welcome to COMSOL Tutorials Hub. My name is Amin and I have a master's degree in mechanical engineering from Hajj Nasir University. Please subscribe our channel for more tutorials. You can contact me through the links provided here.
In this video, we will validate the research presented in this paper, titled Aluminum Nitride as an Alternative Ceramic for the Fabrication of Microchannel Heat Exchangers. Here we have a material properties display, and this represents the shape of our heat exchanger, which is a plate heat exchanger. Due to the symmetry, we can consider only a part of the heat exchanger for optimization purposes. In this model, you can observe the hot and cold flow passages. Now let's look at the mesh. As you can see, it uses structured mesh along the length and unstructured mesh at the circle. From the equations here, we can see that we are solving the Navier-Stokes equations along with the energy equation. Let's take a look at some of the results here. We have temperature profile. First, we open COMSOL and click on Model Wizard. Then I select 3D model and select 2 physics. Heat transfer in solid and fluid and laminar flow. After that, we add the stationary solvent. Okay, well done. First of all, I'm going to add the parameters that I previously wrote and saved the folder. I will open material folder and add the parameters. And same as parameters, I will add the variables that I defined before. Let's first change the legs unit to micrometers. Now let's add a block and define the width, depth and height. I will add a total of 7 blocks. Okay, the block 1 is built. Now block 2. These slides are extracted from the paper, same as the paper, or we should rotate this, or we can change width and height reverse. Okay, done. Let's add the third block. I'm going to write width, depth and height for it, and the position. Okay, now let's add this block, width, depth, width, height and depth. And we should give a position to this block, and I will click on build selected and fifth block. These blocks are cold and hot flow passages for our heat exchanger. And the 6 block, width, height and depth, and a position for it. And the last block, position of last block. Okay. You can see the geometry. It's just a part of our heat exchanger. Okay, now I should use a difference operation in COMSOL to separate these domains. And I would check keep objects to subtract because we want to keep fluid domains. And I click on form union. And let's add the average operators in COMSOL. I will use this average to calculate the average temperature and pressure drop in the variables. Okay, now third average operator. The fourth average operator on a hot flow passage outlet. Okay, done. Variables are fixed. Now we want to define our own material, aluminum nitride. For this, I will add an interpolation function. Here I define domains. All data are extracted from the paper. I added interpolation function for a specific for thermal conductivity. I'm going to give a unit for thermal conductivity and Celsius degree. TSC is the function for thermal conductivity. Then I will add a TSC function of T. Then let's add another interpolation function. For a specific. Let's add a unit for this function, and the input argument unit is Celsius degree, and SHL function of T is our heat capacity at constant pressure. Let's remove the domains that we don't need them. we removed fluid dummies and just keep the solid dummy. As we know, we can define the density as the ratio of thermal conductivity to the product of heat capacity and thermal diffusivity. For this purpose, I will add a thermal diffusivity function like thermal conductivity and specific heat. I repeat that these data are extracted from the paper. No mistake. Let's fix it. What's the problem? THT is wrong. It should be TSC, thermal conductivity ratio to product of heat capacity and thermal diffusivity. It's correct, but what's the error? Let's write it again. The ratio of thermal conductivity to the product of heat capacity and thermal diffusivity. I think it's a bug and it will be fixed. Yes, fixed. For the fluid in our heat exchanger, I'm going to add water. I wrote the aluminum nitrate, name of our material. I extracted data from these plots for thermal diffusivity and thermal conductivity for ALN or aluminum nitride. For the fluid in our heat exchanger, let's add water. Our fluid dummies. Well done. This was for part 1 to model microchannel heat exchanger. For more tutorials, please subscribe.